All right, we'll be starting section 2.1 today. Chapter 2, now we're going to have a chance to get our hands on the data, do some calculations with some numbers, and do things like that. So here's what we're going to do. Organize raw data using what's called a frequency table. Construct histograms, relative frequency histograms, and ogives. All right, and then that's probably about as far as we're going to get today, these two. All right, so what's a frequency table? All right, it does deal with quantitative data, right? Quantitative means things we can make meaningful averages of, not qualitative. You know, if you ask somebody if they had breakfast this morning, that's qualitative. And we sometimes just use bar graphs or like pie charts sometimes. Yes, they did. No, they didn't, right? Because it's a yes, no. But quantitative data we organize differently, okay? All right, so a frequency table does just that. It does break it into smaller intervals or what's called classes, and then the count on how many data values fall into those classes. Okay. All right, so let me show you how we can do this. Let's look at example 1. Go ahead, I'll pause as you go ahead and read that setting. All right, so we got a big set of data, 60 pieces of data, commuting distances to downtown Dallas. So we first have to determine how we're going to get our class width. Okay. 5 to 15 classes are usually used, somewhere around there. If you use fewer than 5 classes, you risk losing too much information. You'll see why once we get into this. If you use more than 15 classes, the data is just kind of too spread out. It's not very well summarized. Okay. So here's the procedure for how we find the class width right here. It says you want to compute the largest data value minus the smallest data value. That's also called the range in math, right? So I put or range. Maybe you want to add that. So the range of our data set, and you divide it by the desired number of classes. Usually they give you that number. Okay, if you're doing it on your own, you probably choose somewhere between 5 to 15. Okay, 5 to 10 is usually probably a little more common. But they will tell you the desired number of classes. That's not usually something you have to figure out. But you got to figure out the range. Okay, so for this one, once you write this down too, so you can kind of see this worked out for this problem, the class width will be equal to, where did I get the 47 minus 1 from? I just looked at that data table on the previous page. Okay, 47 was the largest in here, and 1 mile was the smallest. Okay, so we just subtract them. I'll see the 1. Oh, there it is. Let's say, where's the 1 at? All right, so here we go, back to the work. So that's 46. 46 is the range divided by 6, give me 7.7. Okay, here's a little thing you want to make note of too. You always round that number up. Even if it's 7.1, round up to 8. If you round down, sometimes as you start creating this table, the data values won't fit. Okay, so I'll come back to that concept once we start building it. All right. And that's what step 2 says, right? Increase the computed value to the next highest whole number. Round it up. All right. Okay, continue to read the rest of this, and we'll discuss it. Okay, I forgot to emphasize this, but here's another thing too. Even when you divide this, if this is a whole number, like if this was 7.0, we still round up to 8s. Okay, did you catch that? So even if it is a whole number, round it up. Okay. All right, so how do we start this table? Okay, the lower class limit is the lowest data value that can fit in a class. Okay, so that would be 1 in this case, 1 mile. The upper class limit is the highest data value that can fit in this class. And the class width is the difference between these. Let me explain right here in part D. So here we go. You're going to need to label these. Let's do this first. Let's do some organization. This reads class limits. Write that down. Class limits. Okay, next column is going to be class boundaries. Next says frequency. And some of this we haven't covered yet. It's on the next page, but we'll come back and do all these concepts right here at one spot. And this says midpoint. And then we've got relative frequency. All right, so here's how we get these class limits going. The lowest number was 1 mile. All right, so we're going to create a range of values from 1 to 8. How did I get 8? Because of our class width operation up here, right? We said each one is going to have a width of 8. So 1 to 8 is 8 data entries, if you count the 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so the next one, I don't want to start again at 8. I want to start at the next possible value of 9 miles. Okay, 9 to 16. All right, here's how you can get this going too and use a pattern. Remember, this was your class width. We determined it to be 8. So now what I can do is just keep adding 8 to get this next number. So 9 plus an additional 8, my class width, will give me 17 to start this. And then just make sure you stop to 16. So you can even start with the beginning limits and then kind of backtrack if you want. Does that make sense? So I could keep going and add 8 to get 25. So that means this one had to end at 24. Okay, and then we just keep going until we get to, remember our desired number of classes was 6 in the direction. So 1, 2, 3, 4, 5, 6. All right, you guys aren't ready for the boundaries yet. Ignore that right now. Just focus on the class limits. Okay. All right, you can see how if we rounded down and if I added 7 each time, this one wouldn't include 47. 47 was the most miles. So that's why you round up. Okay, 7.5 or 7, do the math, it wouldn't include 47. So hopefully that kind of makes sense now numerically why we did that. All right, so now to get the frequency, this just kind of takes a while, but let me show you what you do. You go to your data and you figure out how many people drove on 1 through 8 miles or had that kind of commute. So we go through and we say there's one, and you probably cross them out as you go. There's another one. There's another one. Okay, I'm not going to insult your intelligence. I know you know how to do this. Okay, so you just go through and figure that out. Okay, so here's the frequency. Jump over to this column right here until we talk about the rest. So the frequency is 14. That's how many I counted. And then I go on to 9 through 16, and you go through and you tally. It's 21. Okay, so write down the rest of these frequencies. 11, we're in 17 through 24. 6 fell in that category. Then 4, then 4. Okay? Okay, the next concepts are on the next page. Then we'll come back to this table and finish them. Okay, so those other columns are addressed right here. The center of each class is called the midpoint. It's actually one way to do the histograms. Okay, or class mark. I probably won't ever use that phrase, so I crossed it out. Midpoint. The midpoint is often used as a representative value of the entire class. Okay, so all we got to do is add the lower bound and the upper class limit and just divide by 2. All right, simple little midpoint formula. So applying that here, let me get it going. Let me let you do the math because you're smart enough to do that. To find this first midpoint of 4.5, what did I do? I took the lower class limit and the upper class limit. You add them together to get 9, divide by 2, 4.5. Okay? You finish the rest of the midpoints. Pause and do that now. All right, check your midpoint values. Here they all are. Okay, next concepts, class boundaries. So part F kind of describes it. There's a space between the upper limit of one class and the lower limit of the next one. The halfway point, we call it the class boundary. It's a very convenient way to create histograms. So right now that's going to seem kind of pointless, but once we get to a histogram, like, oh, okay, I can see why the class boundaries make sense. All right, so for now, here's what we're going to do. To find the upper class boundaries, we just add 0.5 to the upper class limit, and then the lower class, we just subtract it. So it's going to look like this. Okay. So the class boundary for this first one, they also described it as like a gap, right? What's between 8 and 9? Well, it's 8.5. Or add 0.5 to the upper limit. Okay, the lower limit, we subtract 0.5. All right, so you got to hang with me here. I know like why we're doing this. You'll see once we get to the histogram why we're doing this. So again, the next class boundary, if I subtract 0.5 from 9 and add 0.5 to 16, I get the boundary. Okay, and then we continue that. Okay, I'll pause as you're continuing and finishing that. All right, so there they are. Move on. Pause it if you need more time to check it. All right, let's talk about the relative frequency now. The last missing component of this table. Relative frequency takes our frequencies and changes it into a proportion. Okay? So frequency just means a count, right? How frequent do you exercise per week? You give a number when somebody says how frequent. All right? But relative frequency, now you take that count and you change it into a percentage or a proportion. So simply put, everybody knows how to do that. You do that with test and quiz scores, right? How many did you get correct out of the total? It's a simple ratio to figure out the relative frequency, okay? So they have one little example here for 14 people in that one class divided by 60, because that was the sample size of 60 commuters, is 0.23, and that's what we write down, okay? So there's the first one. I reminded everybody too, what is the n value? So it's your counts, your frequency over n. That's it. So 14 over 60. All right, keep going. Change all these counts, these frequencies, to a ratio, 21 over 60. Continue. All right, here's the relative frequency. Okay, remember, of course, these should add up to 100%. I mean, you might have some rounding errors and maybe 99 or 101, but this should have a sum, put sigma for sum of 1.0, right? Or 100% if we're talking percents. All right, so let's go ahead and move on to the next concept. Completes that table, so now we're ready to go ahead and get into these histograms now. The last things we'll do. All right, what these do is they provide effective visual displays of the data. It's organized into an it's already in the table, and we take it out of table form and put it into a graph. Okay, we use bars, but a bar graph is for categorical data, or qualitative data. All right, so it's gonna be like a connected bar. You'll see in just a moment. Okay. All right, so how to make a histogram? We got to create a frequency table, which we already did. So our first example, we're going to still use that same data. Okay, place the class boundaries on the horizontal axis. Frequencies and relative frequencies are going to be on the vertical axis. All right, so let's get started. So down here, we're going to put miles driven. Okay. Up here is going to be the frequency. Now, does it say relative frequency or frequency? It says relative frequency. Okay, so the y-axis is going to be, the height will be the relative frequency. Okay, and then I can look to the table that we made to see what was the highest relative frequency that we had, and it was 30.35. So that gives me an idea of how I can maybe space this out. I'll just go like 10, 20, 30, 40. That'd be the wise thing to do. So I'll put 0.10. And then once you create a little gap or scale, try to keep that the same width to the best of your ability. So just that we're clear, if it says relative, we do percents. If it's just said a frequency histogram, then I'll do the counts. I'll do like 5 miles, 10 miles, or whatever. Create a scale for that. Okay. All right, now on the x-axis, I'm going to have to chop off the video here, so I'm going to stop.